Hello, it's Shine, and today I'm going to be doing the BlueJ exercises for the Smart Ticket Machine. So first is exercise 2.44, which asks us to create an extra parameter so that we can have a default value for price. So I created that. So let me compile that. Compile, and then we'll create a new ticket machine. This one doesn't take any parameters, it's only asking for the name of the instance. And we'll create one with a parameter with the cost of 30, and we can see that the one without a parameter didn't give any errors, and neither did the one with the parameter. So, and we can see that in the future when we do the other tests. So exercise 2.45, implement a method called empty that simulates the effect of removing all money from the machine. So it should have a void return, and its body should simply set the total field to 0. Okay. It doesn't need to take any parameters because it doesn't have any use for them. It's just setting the total to 0 regardless of what it is so far. So let's test it out. So I'll use the one without a parameter to prove that it works. So we'll put some money in, 150, because the default is 50. Now we can print 3 tickets, and then we'll print 2 of them for now. Print ticket, and I created one called get total because it would be easier to access. So let's get the get total, and so far we've spent $100, right? Because we bought 2 tickets, 50 each. So now let's do void empty, and now let's check get total 0. So it successfully made total 0. Now let's see. This is method need. Okay, so the method is actually in a mutator. Actually, an accessor would return a value. So this method does not return any value, but it changes a value. So that's a mutator. So next one is 2.46. So check that the behavior we discussed here is accurate by creating a ticket machine instance and calling insert money with various actual parameter values. Check the bounce both before and after calling insert money. Does the bounce ever change in the cases when an error message is printed? Try to predict what will happen if you enter the value 0 as a parameter. Okay, so first let's do it in order. Check that the behavior we have discussed here is accurate. So the behavior they've discussed is saying that if the amount is greater than 0, it'll set balance as balance plus amount, and otherwise it'll just print an error message. Check. So then let's test it out. So we have this one here again. We'll create a new object, so it'll be easier. So void new ticket machine, and we'll put the cost of a ticket 50, and then we'll put in some money. So 50. So it says check the balance both before and after calling insert money. So 52. Let's check the balance. It's 52. Let's put in some more money. 103, 104. Let's check the balance. 104 plus 52. So, does the balance ever change in the cases when an error message is printed? So let's test that. So 156 is what we have so far. Let's put in negative money. Negative 78. Let's put it in. I believe it gave an error. Gave the error here. So let's check the balance again. It should have stayed the same, and it did. Because if you look here, the else statement, all it does is print. It doesn't do anything. It doesn't mutate or access balance. It doesn't do anything to any of the prior existing values. It just leaves it as is. So it'll give an error, which is pretty realistic behavior in terms of how it should act in real life. So does the balance try to predict what will happen if you enter the value 0 as the parameter, and then see if you're right. Well, if we enter 0, this condition would be false, so it would still print use a positive amount, which doesn't make sense because I don't believe 0 is considered positive or negative, but we'll just do as it asks. So we'll insert money 0, and let's check, and we have another error message: use a positive amount rather than 0. So my prediction was correct. So let's do 2.47 now. Predict what you think will happen if you change the test in insert money to use a greater than or equal to operator sign. So insert money, we'll change it to greater than or equal to. So I predict that that it will So it's, what do you think will happen? Well, if it's 0, it'll still add 0 in, which is not quite useful, because if you don't put any money, then the balance shouldn't change anyway. So I'd prefer an error message, but this is what it does. Anyway, so I predict that the balance, it will not give an error message. It will just it'll just stay the same. The balance will just stay the same. So we can test it out by deleting this object and then compiling, and then compile, and then new ticket machine. We'll put the cost to 50 again, and then let's try it. So insert money. So test it by, run some tests. So let's put 50. Let's get balance. Oh, price. Let's get balance is 50. Let's try putting in insert money. Let's try putting in -50. Gave an error again, right? Now let's try doing especially what we built this for. 0. Print 0. And let's check it. And no error message. So, but let's check the balance again. It stayed 50. Even there's no error message, but because it's 0, it'll stay the same. Balance equals balance plus amount. So what is the one situation in which it makes a difference in the behavior of the method? If you put in 0. Okay, exercise 2.48. Rewrite the if-else statement so that the method still behaves correctly, but the error message is printed if the Boolean expression is true, but the balance is increased if the expression is false. You obviously have to rewrite the condition to make things happen this way around. So let's read this again because it's a bit confusing. Rewrite the if-else statement so that the method still behaves correctly, but the error message is printed if the Boolean expression is true. So the Boolean expression, so we want it to print this if this is, essentially if this is false. Or whatever is in here is false. So we can actually fix that easily. So if not this will, so if it is this, it'll just change it. So if, this will usually return true if it's over 0, but it'll flip the sign to false. Then we'll print the error message. Yeah. Oops. And then we'll change it as else. So we basically, I don't think it works. I believe it'll work. So let's try. There's not a surefire way to test it. As long as it gives the same result as before, it should be. So let's save it, compile, and then run. New ticket machine, cost is 50. So let's try it. Void insert money. Let's put in 0. Okay, that wasn't a good test case. Let's put in void insert money 50. Let's get balance 50. Okay, looks like it's working. Okay, that's 2.48. So I don't think we really had to rewrite the condition much. We just put a not in front of it. Next, I believe we have to do 2.61 and 2.62. So let's check that out. 2.61 is saying add a new method, empty machine, that is designed to simulate emptying the machine of money. It should reset the total to be 0, but it should also return the value that was stored in total before it was reset. So I believe I created it somewhere here. Empty machine, yeah. So once again, if you read it, add a new method, empty machine, that simulates emptying the machine of money, resets total to 0, and returns the value that is stored. So total becomes 0 here. But if we set total to 0, we can't access it again. So I created a new variable to access total, then total is set to 0, and then we can access what total used to be. Okay, it doesn't ask for us to test it. So I'll just leave that alone to save time. So lastly is 2.62. Rewrite the print ticket method so that it declares a local variable amount left to pay. This should then be initialized to contain the difference between price and balance. So I'll just keep reading it and undo it. This should then rewrite the print ticket so that it declares a local variable amount to balance. So int amount left to pay is price minus balance. Rewrite the test in the conditional statement to check the value of amount left to pay. Amount left to pay, yeah. If amount, so check the value of amount left to pay. If the value is less than or equal to 0, a ticket should be printed. Otherwise, an error message should be printed stating the amount left to pay. Amount left to pay. If it's less than or equal to 0, the ticket should be printed. So it'll print this ticket. Otherwise, it will give an error message saying the amount left to pay, which is price minus balance. But we can just put in amount left to pay now. Amount left to pay, because this is a replacement for whatever was previously. Okay, test your version to ensure that it behaves in exactly the same way as the original version. Make sure you call the method more than once when the machine has different states. Okay, let's save it, compile, and new ticket machine. Let's put a cost as 30 this time. So let's try it out. Int insert money. I'm going to put in $57 or whatever value it is. Then print ticket. It printed, okay, I guess it's cents, but it printed the ticket for 30 cents. Now let's print the ticket again, and it should, yes, because the amount left to pay is 27. So, I mean, the amount we had, the balance, if you check here, get balance, it's 27, and we needed 3 more cents, which is calculated by the amount left to pay. So I believe that works perfectly fine. Make sure you can handle negative money inserted, refund the balance, and empty the machine if the money is collected by printing tickets. Yes, we can do that one as we proved with the empty method. Refund balance, we can check that, but I believe it will work. And handle negative money, we tried it earlier. So yeah. So let's try refunding balance. Refund balance. And yeah, it returned 27, which is the balance. Now let's check balance. 0. Okay, works perfectly. Thank you for watching. I have attached the notebook in the Google Classroom.